Hello and welcome to all students in this our YouTube channel. Students, we are in the topic of structure of atom, and in this our topic in our previous lecture we have seen different quantum numbers. Students, in continuation with that previous knowledge, we are going to learn the next part of this chapter is nothing but the shapes of atomic orbitals. Now students, according to the Max Born, the square of the wave function at a point gives the probability density of the electron at that point. Means according to the probability density of the presence of electron, we will decide the structure of that corresponding or the shape of that corresponding atomic orbital. So with this knowledge, we will decide whether s orbital, p orbital, d orbital and f orbital has different shapes and which types of shapes are present. Now we are going to learn one by one. Now students, for 1s orbital the probability density is maximum at the nucleus and it decreases sharply as we move away from it. Means if you look at the shape of 1s orbital, it will be like a circular shape and it will leads like a sphere. Now students, for 2s orbital the probability density first decreases sharply to 0 and then again starts increases. Now in pictorial diagram in our next slide we are going to learn how its shape will be present. After reaching a small maxima it decreases again and approaches 0 as the value of r increases further. Now students, the region where this probability of finding of an electron which reduces to the 0 is called nodal surfaces or simply nodes. Means at the center, if we consider the particular shape of s orbital at the center, its probability will be maximum, and if we move from its center, its density gets decreases, and the region where this probability of finding of electron reduces, that point we are calling it as a nodal surface, or simply we are calling it as a nodes. Now students, in general for an ns orbital, in general s orbital, and ns orbital has n minus 1 nodes. That is, number of nodes increases with the increase of quantum number, that is n. Therefore for 2s it will be 1, for 3s it will be 2. Now students, boundary surface diagrams of constant probability density for different orbitals gives a fairly good representation of the shapes of the orbitals. In this presentation, a boundary surface or a counter surface is drawn in a space for an orbital on which the value of probability density constant. Now students, in the boundary surface diagrams, the nucleus is taken to be at the region, or further it is there. Here diagrams are not spherical like s orbitals. So look at this picture, you will notice that boundary surface diagrams of 2p orbitals. Here the p orbitals consists of two sections, s called lobes, that are on the either sides of the plane. Look at this picture, you will notice that if we consider the x-axis, at the both sides the two lobes are present that are on either sides of the plane, where the energy of the three orbitals are identical. Since the lobes are considered along the x, y and z axis, they are designated as the above 2px, 2py and 2pz. So if you look at this diagram, you will find that in the first diagram the lobe which is present on exactly x axis and the lobe which is present exactly on the y-axis in the second diagram. We are calling it as a, or we have named that corresponding orbital as a 2py. And if you look at the third diagram 2pz, the two lobes are present on the exact z-axis. One is the positive lobe and another is the negative lobe. So according to that, it should be understood that there is no relation between first magnetic quantum number and xyz directions. So this is all about the diagram for 2px, 2py and 2pz. So these are called as a 2p orbitals. Now students, after this we are moving to the next orbitals, that is d orbitals. The 5d orbitals are designated as dyz, dxz and dx square minus y square and dz square. In this orbital, dxy orbital is also present. So totally the suborbitals we are calling it as a 5 suborbitals. The shapes of the first 4d orbitals are similar to each other, whereas the fifth one is different from the others. But all 3d orbitals are of equivalent energy. So the d orbitals for which the n is greater than that of the 3 also have the shapes similar to the 3d orbitals but different in energy. Now students, when two nodal planes pass through the same origin and bisecting the xy plane and z plane, these nodes are called as angular nodes. Now what is meant by angular nodes? We will go in detail and it will be denoted by the letter small l. There are one angular node for the p orbitals and two angular nodes for d orbitals. The total number of nodes are given by n minus 1, that is the sum of l angular nodes are n minus 1 l radial nodes. Now students, if you look at the energies of these orbitals, energy gets increased is we have represented in increasing order of the orbitals as given as follows. 1s orbital has at the lowest energy level and 2s has the greater energy than that of the 1s. And if you look at the energy of these orbitals with respect to 2p and 3s, that going on increasing, it will be represented by these notations. As 2p and 2s orbitals are different, an electron has the same energy as it is present in the 2p or the 2s orbital. Now students, the orbitals which have the same energy are called degenerate. The 1s orbital in a hydrogen atom corresponds to the most stable condition and is called the ground state, and the electron residing in this orbital is strongly held by the nucleus. Now students, the electron residing in the 2s, 2p or higher orbitals in the hydrogen atom are said to be in the excited state. The attractive interactions of an electron increases with increase in the positive charge on the nucleus. Now students, due to the presence of electrons in the inner shell of the electron in the outer shell, we will not experience the full positive charge of the nucleus. The effect will be lowered due to the partial screening of positive charge on the nucleus by the inner shell of electrons. This is known as shielding or outer electrons from the nucleus by the inner shell of the electrons. Shielding effect means what? That we should understand first. Shielding effect is nothing but there is a repulsion between the outer electrons and the electrons which are present in the inner shell, because the electrons experience the same charge, and we already knows that this same charge or the like charges repels each other. According to that criteria, they will repel each other, and due to this shielding effect, the atomic size of that corresponding atom gets increases. Means due to the shielding effect, atomic size of the any atom gets increases, means atomic radius gets increases, and the net positive charge experienced by the outer electrons is known as the effective nuclear charge, and that is denoted by Z effective. In other words, the energy of interaction between the nucleus and the electron decreases with the increase in atomic number, that is Z. Now students, after this we are going to learn the next principle, that is above principle. Why this principle is important for the in this chapter, or to study the details of these atoms. This is the principle which gives us how to fill the electrons in a particular suborbitals. Above principle which deals with the filling up of electrons, the principle states that in the ground state of the atoms, the orbitals are filled in the order of the increasing energies. So students, we should learn first of all the increasing order of the energy levels. In other words, the electrons first occupy the lowest energy orbitals available to them and then enter into the higher energy orbital only after lower energy orbitals are filled. Now if you look at the order of increasing order of energies in the orbital, it will follows this rule. First of all, electron should fill in the first, that is 1s, then it will enters into the 2s. It will, after filling complete this suborbital, that is 2s, it will enters into the 2p, then 3s, 3p, 4s, 3d, 4p, like this. And if you look at its overall diagram, how to fill the electrons, its order of filling up of electrons is shown by this diagram. Means electron will first enters into the lowest energy level, that is 1s. We have shown it at the top of the diagram. After filling this 1s orbital, electron will now enters into the 2s orbital, then it will enters into the 2p, and according to the direction of arrow it will enters into the 3s. So students, this is a very important diagram which is you will you can learn, and by knowing this diagram you can fill the electrons into the increasing order of the energy levels. And if you want to write the electronic configuration for a particular atom having atomic number above 30 also, you can write the electronic configuration correctly. Now students, after this, Pauli's exclusion principle is the second principle which shows the direction how to fill the electrons. According to this principle, no two electrons in this atom have the same set of 4 quantum numbers. So this will also helps how to fill the electrons, means their direction should not be parallel, or we can say the upward direction or the downward direction. Means along with that, or with this concept, we can say that electronic configuration, before going to fill the electron into the corresponding suborbital, the 4 quantum numbers are not equal, or we can say 4 quantum numbers may be different, or sometimes if the 3 quantum numbers are of same value, then the 4th quantum number you will not get the same. Means it indicates that according to the Pauli's exclusion principle, no two electrons in this atom or any particular atom have the same set of 4 quantum numbers. It can also be stated otherwise, as only two electrons may exist in the same orbital and these orbitals must have opposite spins. The maximum number of electrons which can be accommodated in the shell with the quantum number n is according to the rule, that is 2n square rule. Now students, In our next lecture, we will learn the Hund's maximum multiplicity rule. So, this is all about in our today's lecture. So, thank you very much.